Well, hello students, welcome to this class with me, Mr. Alfie. And this is mathematics class.
In this video, we are going to learn about sub-language and notation, which is the first chapter in our book. In the next slide, we will know the definition of set and example of sets. Set is a collection of well-defined objects. What does that even mean? Which means you can decide whether an object is belong to a set. For example, the first set is a lion. So if you find lion, you can put it in this set. The next slide, it'll tell the set is usually written by capital letters. It's always capital. A capital, B capital, and etc. The objects in a set is what you call element or member. It's usually called element. So if a set of lion, then the example before, so the element of set lion is lions. And then for example, let's n is a set of positive integer less than 6. Positive integer less than 6. In this following slide, you can see there are 3 ways to write element of n, which is n, which element is x is positive integer less than 6. Or the second way, you can write it by x, whether x more than 0, which is positive less than 6. And then the third way, you list every possible element of n. More than 0, less than 6, which means 1, 2, 3, 4, and 5, and 5. And then 1 is element of n, as you can see, but 8 isn't element of n. This notation, that's what you call set notation. For the next slide, I ask you to open page 5 in your book in example 1. Given that set C, letters of word student, express the set C by listing its element. It's the third way, the listing element. So, as you can see, the element that constructs students, which S, T, U, D, E, and M. So, is D an element of C? Yeah, because D is inside or include in C. So yes, D is an element of C. You can donate it like this slide. In the next slide, we are going to talk about equal set, which is from page 6 in your books. I need you to open page 6. Two sets, A and B, are equal if A have exactly the same element with B. So element in A, also element in B, exact element. For example, let A is letters of word parallel. It's on your book, page 6. And then B, letters from the word apparel. So is A equal to B? Let's find out. So the first way to solve it is by listing elements in A and listing element in B. So this slide, as you can see, element of A is P, A, R, L, and E. And element of B is A, P, R, E, L. So is A equal to B? As you can see in this slide, every letters in element A is also letters in element B. Whether they are the same order or not, they are the same. So A equal to B. It is A equal to B. And then we're going to talk about subset. Still, I need you to open page 6 in your book. Subset. What is subset? In every element of set A is also element of set B. Then A is said to be a subset of B. Denoted by, you can see at the slide, A subset of B. What does that even mean, sir? So as you can see, like the example, suppose A is 3 and 5. B, given the element of B, 3, 5, 7, and 9. As you can see, every element in A is also element of B. As you can see in this picture, every element in A is element in B. So A inside B, that's what we call A subset B. A inside. Okay, for the next slide, I want you to open page 9, exercise 1.1, number 8. As you can see in the slide or in your book, to list every element in each set. For set C and D, the element already listed. We're going to find element of A and B. Element of A, integer greater than 0 but less than 4, which means 1, 2, and 3, as you can see at the slide. And then for B, the root of that equation, that is a quadratic equation, and the root is 1 and 2. So we have got all of element in each set, A, B, C, and D. And then we're going to define the relationship between A and B. The element of A, 1, 2, 3. The element of B is 1, 2, which means B is actually subset A. B inside A. So A and B. A is not subset B. A is not subset B because B is subset A. Okay, for B, A and C, between set A and set C. As you can see, A is 1, 2, 3 and C is 3, 2, 1. Remember, every element in A is element in C. What does that even mean? As I said before, it means A equal to C. Okay? Next is between set B and set D. Okay, B is 1 and 2 and D is 0, 1 and 2, which means every element in B is element in D. So, but not exactly the same, because in D there is a 0, but in B there is no 0, which means B inside D, which means B is subset of D. Okay, and the last one is between set C and set B. Set C is 3, 2, and 1. Set B, 0, 1, and 2. Say it's not subset D, and also say C is not the same with B, which means C is not subset of D.